Okay, we're going to practice recording this for Chelsea and for Dylan. Yeah, even though we don't usually record the homework thing, we'll try it. Oh, we'll try it, maybe. I'm tied to this thing now, though. There. Yeah, yes, she could have. All right, here's the first question. How'd she go? Oh, this was good? Right, this is the one I kind of helped you begin, right? Kind of helped you begin. You had to start with acceleration of negative 32. Even though they told you acceleration was 32, you had to know it's negative because it's always pulling you down. What do you want to talk about here on this one? Nothing? Oh, oh. Oh. Can I do that? No. Oh. And I forgot my glasses, so I can't even see either. There. Page 2. Was drawing this troubling? Yeah, drawing this was troubling. Okay. Well, first, I just plotted points on a piece of paper. This is number, sorry, can't see, 15. Plotted that parabola. So do you want to talk about how I got those points on the paper? So for example, I know that, let me get my pointer going over here, there we go. I know that 0, negative 1 is on the curve. So I put that there. I know that if I plug in a half now, right, I have to do half squared minus 1, which is a quarter minus 1, which is negative 3/4, right? That's on the curve, half negative 3/4. That's my second point. Let me see if I can get a pen here. There we go, right there. This next point, point number 3, is plugging a 1 in. If I plug a 1 in, I get 0. Right? If I plug 3/4 in, that's my next point, and then finally I plugged in 2. That's how I'm up here at 3. Is everybody okay with the graph of the actual parabola curve, just plotting points? Okay. Then it said, write out the Riemann sum for f on P in which x is the right endpoint of each subinterval. So what I had to do was draw rectangles where the right-hand side touched the x-axis. If you look at this first one, I know it's going to be down below. It's going to be inscribed in the case of this one because I'm using the right endpoint here. So it has to be inscribed. Only if I were using the left endpoint would it be circumscribed down there. Does that make sense? Okay. This next one looks like it's not even there. Why? Because it's not even there. Right? That's the 0 area rectangle right there, that little guy. And then there are 2 more. Right? These guys happen to be circumscribed. Again, it's just depending what your curve is. And the right endpoints are the ones that touch here. So there are your 4 points. 1, 2, 3, 4. This first one isn't used because that would be left endpoint. So over here, I know the bases of these are half. And then I know I want the y value at the next 4 points. I want the y value at half, at 1, at 3/2, and at 2. How do you get these values right there? Yeah, you just plug them into the formula, right? You plug a half in, you get the y value. You plug 1 in, you get the y value, and so on. Send this to Chloe. anybody still confused on that one? Okay. Let's come on down to the next one. This one you want the derivative. This was a drop it in. Did anybody want to talk about that one? Number 16.
So once you drop it in, it automatically just goes to the derivative, and it's automatically that's prime after you drop it in?
When you're taking the derivative of an integral is when you drop it in.
Yeah.
Yes. So if you're taking the derivative, basically the derivative and the integral cancel each other out, which is why you don't really do anything. You don't really do any calculus.
Yeah.
The only thing that you would be doing was be multiplying by the derivative of x, which was 1. Yeah. Okay. Can't pull down using a pen. Come on. Okay. The next one, 17. How we feel about that?
Can we do this one? Yeah.
You're not a fan of it?
No.
Okay. We'll see what I can fit here with my crazy writing. I haven't done this in a while. Okay. Did you know what to make your u? Yeah.
I have a question about that one.
Yeah.
Do you only drop it in when the X is on top?
Yes.
So if it's not,
You have to put it there. Yep. Send this to Lauren. Did we know what u was supposed to be for 17? Yes? Okay. So let's go there. I'm going to try to do this with no glasses, so bear with me. So here you'll have 2 minus u to the half squared du.
so you just leave the 2 there, like you don't do anything?
Yeah.
It's hard.
Sure. Oh, that was your trouble?
Yeah, I didn't know what to do with it, but can you still? Yeah.
Okay.
Yeah.
Finding the limits of integration. Is everybody okay with that? Plugging in a 0 and plugging in a 3? So if I plug in a 0, I get 1, right? Plugging in right up here. Plugging in a 3, I get 4. Good? At this point, there's not a heck of a lot you can do because of that squared, so you have to FOIL. That's actually what I did in the next step, although I did the shortcut FOIL. Want me to talk you through the shortcut FOIL? Okay. I did square the first, so I squared that. That's 4. I did multiply these two together. That's negative 2 u to the half. And double it. That's how I get negative 4. And finally, square the last, which will be plus. If I do half squared, remember these numbers multiply. So this is just plain old u on the end. Du. That okay? Shall we keep going? Okay. From there, I'm going to integrate. This is 4u minus 4. Increase the power by 1 here. That'll be u to the add 2 over 2. 3 halves times 2/3. And this one will be 1/2 u squared. 1 to 4. It's okay? Okay. And now you're going to do fundamental theorem of calculus, which I'm not going to be able to fit here. Plugging in the 4 first, and then subtracting and doing the 1. Want me to do that up on the board? Yeah? Okay, sorry to those folk, they can't see it.